All right, well, I will continue on. Running jobs, and while I'm loading this up, can we get a show of hands by raising your hands, who all is new to either submitting a parallel job or using a supercomputing system? Who has never done this before? Quite a few hands going up. All right, so for those of you that are new, this is going to be a lot of information, a lot of acronyms, a lot of terms. Don't feel overwhelmed. It takes a little bit of time. So if you are new to HPC, we want to welcome you. And a few things we're going to talk about in this talk or this section of the training is understanding what a job is, how to run a job, understanding a few of the workflows, container environments, and best practices of making the use of your allocation on Perlmutter. So getting started, basic job submission details. So what is a job? In the computational sense, when we say a job, we are basically talking about you doing a computation on a shared resource. And that resource can be a GPU, it can be a CPU core with threads, it can be you using a whole node or you using a shared node as well. So in order for us to allow for users to submit a job, we make use of a job scheduler. And the job scheduler basically manages your request for specific resources and basically puts you into a priority based off of what you need for a number of factors. And in order for a job to be submitted for the job scheduler, you have to have a job script. And so the script is basically asking you to outline all of the resources that you are going to need to make use of, any number of nodes, whether you're using CPU only, GPU, threads, or other parallel constructs as well. And then you can also have a type of job. An interactive job is another job where resources are allocated in real time. It has specific limitations on you being able to run that interactive job. So at a high level, that is all of the kind of constructs of what a job is. But let's talk a little bit more. So again, how are jobs managed on Perlmutter? So Perlmutter, we use a workload manager called Slurm. And Slurm is not just analogous to Perlmutter, it is an open source scheduler. But with Slurm, we have provided a few optimizations to make it more efficient for usage on Perlmutter. So 3 key responsibilities that you want to keep in mind when using Slurm is that it is going to be allocating the resources to your jobs. It allows for the execution and monitoring of those jobs as they progress or wait in the queue. And it also manages the priorities of the jobs that are submitted. So it's important to keep in mind that how you construct your job script is basically how Slurm is going to determine your priority. And you can think the higher the priority is, the higher the cost it will be for you, for your allocation. So again, even if you've used Slurm on other resources, we've configured it differently for our system, and most of the time that's common as well. So Computation 101, when you connect to Perlmutter, you're logging into a login node, and so that includes if you're logging in with a Jupyter session as well. Do we have Sandoval, did you have a question or just your hand was still raised? But if you do have a question, feel free to interrupt. We're also in the Q&A document as well. So one thing to keep in mind is that login nodes, they are not meant for large computing tasks. These are all shared by all users, and we only have about 40 login nodes. So whenever you go to do a large scale computation or simulation, your job is going to execute on our various compute nodes. So in Perlmutter, we have 4,864 compute nodes, of which we have CPU only nodes, 3,072, as well as the remaining being GPU nodes as well. So it's important to keep in mind whether you're going to need to make use of CPU nodes or you'll require the use of GPUs as well. So there are different ways in which you can access a compute node. You can do an interactive job on a compute node as well. And so with that, you directly connect to that compute node. You can use command line interface or also submit SRun requests, and you can request a Jupyter notebook on that compute node as well to do any type of visualizations or simulations too in computations. The most common that most of our users make use of for large scale simulations are going to be batch job submissions. And in order to do a batch submission, you submit a batch script that gets submitted to Slurm, and then Slurm takes your batch job script and it analyzes it and prioritizes where it's going to go into the queue. So it's important to make sure that you tell Slurm everything that the resources that you're going to need to make use of. So these are a number of different Slurm back flags in short form and long form that denote some of the priorities that Slurm will take into consideration in placing you within the queue. So you want to make sure you specify those values appropriately and within specify them at your job script. And we'll go over a few examples, but at a high level, we have the nodes flag, and that's going to request the number of nodes that you are going to need for your computation. And you can imagine, depending on the load of the queue, the more nodes you request, probably the longer you're going to have to wait. So it's normally better if you are testing things out to do like a small little benchmark test or a few iterations so that you can either do it interactively or just grab a few nodes quickly. You'll also need to denote in tasks. That's going to be the number of MPI ranks or total tasks that you need. You'll also have to specify your account, which is the project that your job is going to be charged against. You'll also need to determine and identify the quality of service, and this is basically the type of queue that you're requesting to use, and we'll go into more details of those different qualities of services later. And then if you have a constraint, whether it's CPU only or GPU nodes as well. And also another most important thing is the wall time requested. It can be a bit of a revolving or changing, because if you request a lot of nodes and a long runtime, then I can guarantee you will be waiting for a while. So it's kind of understanding like, okay, the quicker the job, the less number of nodes, the higher your priority will be in getting your job done. So how do you get an interactive job from Slurm? You use a salloc command. And with salloc, you can allocate in real time all of the resources you need for an interactive job versus a batch job submission. So you see in salloc, we have a number of the same short form flags that we previously discussed. It's saying the account that is going to be charged to, in this case, M4388. We're only requesting a number of one node. We've had a limit of our wall clock time to 10 minutes, and it is a GPU node that we're requesting. So once you hit submit, Slurm will give you your job number, this number here. Then it'll update you once your job is in the queue, then once your job has been allocated, and then once you're granted that allocation. So it will update you. And again, once your node is ready, it'll let you know that message too. So at a high level, this is a quick way for you to, this is the easiest way for you to do an interactive job. But again, the more nodes you request or the higher the wall clock time, then that's going to affect how quickly you'll get your resources. And so I just previously went over, but this is kind of breaking everything down. You know, we have the salad command that gives you the compute nodes to use. You know, -A, that is the account that you're being charged against. So, you know, it's going to usually start with the M. A lot of times if you get like the exact, I can't remember the exact area, but it's like something like your submission does not fall into job guidelines or something. A lot of times that's because you've either submitted like a wrong account or the QoS is wrong or something like that. So any errors like that, you'll get a pretty generic message back from Slurm. And then again, the constraint is whether you're using GPUs or only CPU only. And so when do you want to use an interactive job? Interactive jobs are quick for, you know, any kind of proof of concept type of testing, quick testing and debugging. The less number of nodes, the quicker the time, the easier you'll be able to get that resource allocated. Now, there are a few limitations for interactive jobs in that, you know, you select your QoS being interactive, and with that, you are only limited to at most 4 nodes, and you can only use 4 hours of 4 hours wall clock time. And that's for if you are using a not shared, like you only want to make use of the resources. Now, if your QoS is shared, then you're able to get a higher number of nodes, higher wall clock time, and you can use half of the node max. So this could be, you know, 2 GPUs, 32 cores, 64 threads. So there's a trade-off if you need exclusive access to a node versus you're willing to use shared resources. So how do you get a job from Slurm? With interactive jobs, and this is just a quick, if you haven't used Jupyter Hub yet before, Lippy is going to talk about Jupyter Hub next. But when you go to Jupyter Hub on jupyter.nurse.gov, you log in and it'll present you with a number of different options. You can do a login node, you can request a shared node, exclusive CPU node, exclusive GPU, or you can configure for specific settings. So these are a few different ways in which you can request an interactive allocation with Jupyter. But that, again, you have limitations with that. So if you are needing more resources, what you're going to want to do is use a batch job submission. And a batch job, with a batch job, what it's going to do is going to analyze your job script and place you into the queue based off of those parameters. So with a batch, you have more time outside of the 4-hour exclusive or 48-hour shared limit. You can schedule more compute nodes and, you know, more than the 4 for an interactive job. And so we'll go over an example of a job script, but this is the basic Slurm command to submit a job script. It's sbatch, and then the name of your job script, and the prefix is sh. So once you submit that, it will give you the job ID, just like with the interactive job. So again, that sbatch command is what you use to submit that job script. And then what does a job script look like? So at the top of it, and by default, you'll just have your bash command, and then you'll have hashtag sbatch to the node that you're submitting a batch script comment. And then you'll have your different flags that you're using to outline all of the information, your account, the QoS or queue you're going to use, the number of nodes you need, the time, the constraint, CPU or GPU, and other things that you can factor into. Now, you can also name a job instead of getting like a number. You can have your job name be something like science. And so that allows for you to also provide for different outputs from the execution of your job script, such as, science dot, out or science dot the errors that occur. So, and at the end of the job script, you'll have your srun command, which is going to specify those specific constraints, whether you want to bind the CPU cores and if you have any specific hosts that you want to use as well. And so with Slurm, it adds those environment variables, slurm in nodes to get the requested number of nodes. Then the slurm run command is just srun. That's similar to if you've done any other type of parallel jobs like MPI run or MPI XE for other MPI jobs. So Slurm is one type of job schedulers. There's others like AIX and then other different schedulers that you can make use of. Then the host name is going to run one host name per node. And so we talked about the quality of service or the queue options that are available. So there are different queues with different limits that you can make use of. You can make use of the debug queue. Some constraints with debug queue, you can access 1 to 8 nodes, and it has a limit of 30 minutes max. And that's good for just testing your script, trying to do simple scaling runs across a few number of nodes or resources. And you can get that in regular or shared as well. And so with regular and shared queues, we also have, this is probably the most, the highest quality of service used. So you have a 24-hour max wall time. You can do 5,000 job submissions. So with that, the queue selection or QoS is going to be regular or shared. And then with shared, you have half a node max per job. So most of our users make use of the regular or shared queue. So there are different ways in which you can also debug your script. So there are different things to make use of. You can do a few scaling tests, use QDebug, and then you can also scale to test the performance from a number of nodes or other CPU or other threads that you need to make use of to see how your application is performing. Okay, and so a few examples of how you can make use of a shared queue. So here we have just an example of a 2-rank MPI job. And with shared, it allows for jobs from different users to share a different node. So shared jobs are only charged a fraction of the node resources that are used. So it's beneficial for running small parallel jobs. And you can have a typical use case where you maybe can run a serial job as well on a shared node for a small number of tasks as well. So, all right. So if you are not familiar with hierarchy and large-scale compute systems, you might need to take a moment and look over this a little bit of time. But our CPU compute nodes are organized into what we call 2 sockets with 4 NUMA domain sockets. So that's about 8 per node. And each core, you have a core from 16 cores on each NUMA socket. So it has 128 physical cores and 256 logical cores when you take into threading and other parallel constructs to make use of. So you have memory access on remote NUMA can be a little bit slower, but it allows for you to kind of configure your job and optimize it if you're able to, based on logical placement, and if you're familiar with the memory organization of your application and compute and how it's going to compute, you can have a little bit more control over that. And there are a couple of different commands that you can make use of. Linux specific, so you can get like the CPU info that is available and the hardware counter info that is also available as well. And so it's important to understand the differences between different types of affinity that you can use for submitting your jobs. So when we talk about process affinity, what that is saying is we're binding an MPI task to specific CPUs. Logically, you cannot have more MPI tasks than you do have those cores available. We have thread affinity, and that's going to bind threads to our CPUs allocated to its MPI processes. So for each MPI process, you can have a number of different threads. And then you also have memory affinity, where you can allocate memory from specific NUMA domains that we kind of discussed as well. So you want to make sure that if you do use these, you want multiple processes, you want to make sure you do CPU bind to cores so that you don't have multiple processes trying to do work on just the same core, which is inefficient, right? That defeats the whole purpose. So, that can hurt your performance. So please make sure in our documentation is very detailed, giving you a kind of an overview of different type of affinity settings that you can make use of. And later, we'll also discuss the available job script. And the job script is great. If you don't know exactly the flags you want to set, you can enter some commands at a high level, and the job script will generate the script for you. So understanding a couple of components related to Perlmutter. Perlmutter CPU cores, as we mentioned, physical cores, you have 128. This is on CPU only. You have logical CPUs per physical core of 2, and then logical CPUs per node of 256. NUMA domains are of 8. And now when you consider a GPU node, GPU nodes have both CPUs and GPUs. So physical cores are going to be 64. The physical CPU cores will be 64. The logical CPUs per physical cores is still 2, but you have logical CPUs per node, or 128. And you have 4 NUMA domains. So, understanding the C value for your SRUN and or the TPN is going to be the number of MPI tasks per node. So you would be 2 times that 4, or 128 over the TPN that you need. So options for MPI codes. And we get a show of hands of like a few different things. So I'm going to ask if you can raise your hand if you know you will be dealing with MPI on some of your applications on Perlmutter. Do you know if you'll be making use of MPI? If you want to raise your hand. Okay, cool. So at least we got about at least 10 hands raised that say that they will be making use of MPI. And so there are a few different constructs that you want to keep in mind when running MPI codes. When you're setting the address for your NUMA memory performance, you want to use your CPU bind cores, and you want to make sure that the MPI tasks are going to be less than or equal to the number of cores that are available. When you're using CPU bind threads, you want to make sure that the MPI tasks are larger than those cores when you are larger than those cores. And for here, you'll get that C times the floor value of 128 is going to be where that TPN is going to be 16. So that's going to give you that high level that you can execute with. So the SRUN command for this MPI batch script, we have it's requesting 2 nodes, a time of 8 hours, CPU only, name the job science. And so we have the SRUN command is going to be requesting 32 MPI processes with 16 cores, or the other way around, I'm sorry, 32 threads 16 MPI, and then you're going to bind to the cores. And then this executable is just right here, whatever your A.out is, or whatever your executable that will be running. Now, if you want to export, if you're going to be making use of OpenMP, and by a number of hands, who is going to be making use of OpenMP in their applications if they know? Anyone else know that they'll be making use of OpenMP for threading? So who can tell me one difference between an OpenMP code versus a MPI code? What is one main difference between using an MPI code versus an OpenMP code? Okay, and Preeti says shared versus distributed memory. And could you further clarify that? That's correct. So really what you want to keep in mind is with OpenMP, you're making use of threads for shared memory within a node, but you can't do that with more than one node for OpenMP only, unless it is logically connected with it together. So you would need to make use of MPI if you needed multiple nodes. So that's one thing that you want to make sure you consider and understand. So a number of different libraries by default make use of OpenMP. And thank you, Anupam. And like most common scientific libraries, BLAST, LAPACK, NumPy, and Python make use of it. And in order to set your OpenMP threads, you'll export OpenMP number threads to 8. Your places, number is going to be cores, and then the processor binding if it's going to be spread. And then you can just simply submit your job submission for an OpenMP. So a common, option if you're going to be making use of shared memory across multiple nodes is going to be hybrid codes of OpenMP and MPI. By a show of hands, who is aware if they are going to be using hybrid OpenMP and MPI application codes? Have a show of hands who knows if they're going to be covering hybrid OpenMP or MPI codes? Or even you might have an MPI code and you might want to further parallelize it by introducing OpenMP or other threads as well, too. So Helen has mentioned that, next Monday, supercomputing crash course that Helen, I, and Rebecca will be leading is going to give you a detailed overview of MPI and OpenMP as well. So with that, with a hybrid code, you'll still select your number of nodes. You'll also be able to select the number of threads that you want to make use of in those placements as well. So a lot of applications might start off as making use of distributed memory, and then they're further, hierarchically parallelized to make use of threading as well. Then we also have GPU codes, options for GPU codes that you can use. Who knows if you'll be working with a GPU type of application this summer? Show of hands if you'll be using GPUs heavily in your code this summer. Okay, awesome. And so with the GPU codes, you can specify the number of GPUs per task that you want to use. You can do more advanced options like a GPU binding as well. Then you want to make sure your C value is going to be equal to that floor over a TPN of 4. And so with our SRun command, and you can also use GPU codes with OpenMP threads as well. So you can get a lot more hierarchical with the way that your applications are constructed, and understanding a lot of these parameters can be tricky, which is where the job scheduler that we have available comes in really handy as well. All right. We're halfway there. This is a lot of information. I got about, I think about 15 to 20 more slides to go through. Bear with me, and if this is completely new or you're just completely lost, don't worry about it. It takes a little bit of time. You'll be able to watch the video recording and all of the resources as well. So some of you might be needing to do, some of you are only just going to need to be doing, a few job submissions that don't have to do things in parallel. But Slurm does also have the capability to allow for you to bundle different jobs. So you can run, multiple executables sequentially or simultaneously to improve your efficiency. A couple of different options that you can make use of is using a Slurm job array. So if you have, the same job task with different inputs, then what can happen is you can configure a job array and Slurm can execute those for you. Then there are other workflow tools. Nurses become heavily invested in, workflow tools and figuring out ways to make some of the other things more automated. So we have other tools available, the new Parallel. You can do small tasks in one node, and then more complex workflow tasks like Parcel and Fireworks as well. Okay, and so if you need to bundle jobs within Slurm, so if you have jobs that are running, that can run sequentially, you can enter all of those jobs, specify the total time you expect for all of those jobs and more. And then your schedule, you can submit them and the scheduler will execute each of those jobs accordingly. You can reuse the same allocated resources for different steps in your workflow. So that's one way in which if you need to submit multiple jobs, you can just submit it this way if they're going to require a top level of the same resource. So if you want your jobs to run simultaneously, what you want to do is add the AND flag and then also in wait. And so this will only wait to have for the scheduler once. And this allows for the same program with different inputs per SRun to execute. So if you have a number of resources and you want to test out different inputs, you can do it with this way. Another way to do it is also using job arrays. And so with job arrays, Slurm manages each job independently. So if you have one task that fails, it won't affect the others. It's good for getting using for large statistics on same input files or doing parameter sweeps over different input files. And so with your sbatch command, you'll add in your array here, as well as your, echo out your Slurm array job ID as well. So job arrays can be, depends on the type of workflow that you're looking to do, can be a little more complex, and it might not be what you actually need. But then also other tools available, the new Parallel, you manage tasks inside of the allocation. So if you have a number of, many small tasks, this is good for faster start times in SRun, that you can reuse your allocation for all of those tasks. So as the task finish, the next one can start, and you can use your allocation efficiently. In order to make use of this within Slurm, you want to make sure that you do a module load parallel in your sbatch script, okay? So with Parallel, you execute the Parallel, J command, and a few of these inputs. We just provide a high level overview of how you can make use of it. We have more detailed examples within our nurse documentation as well. So if you have more complex workflows with dependencies, you want to try and make use of some workflow management system tools like Parcel, FunctionX, and Globus Compute, Fireworks, and you want to make sure you write code that can define your workflow to help you perform your simulations most efficiently. We have a number of resources available in different trainings on workflows. Helen, are you aware if we're going to have any other upcoming workflow trainings?
We had a recent one on May 30th, and you should be able to find recordings on the workflow tools training on our training website.
Awesome. Yeah, and all of our previous trainings, we keep those resources available for access. So even if we don't, like for workflows, we just had it, you can go and look through the recording and the materials there. All right, now moving on, let's talk about running jobs in containers. Nurses heavily been focusing on making sure users make use of containerized environments because it's easy because it allows for you to port your software environment to different systems. And so it can help with decreasing the start time of large jobs. At Nurse, we support container technologies of Shifter and Podman for building images on login nodes. We don't support Singularity or Apptainer on ProMuter. So these are the two recommended for you to use. So what is a container? If you're not aware, a container is just a nice way for you to package up the software that you need and easily take it with you to different systems. Containers make use of Docker or Docker is just one form of a container technology that you can make use of. And so, you can build a container, different commands, Docker build, you can ship it, and then you can run it variously as well. So in order for you to be able to run your container on ProMuter, you need to make sure that you ship it to the Nurse registry. So registry.nurse.gov. You'll want to make sure you do the build and then ship. And then once that is there, you can run with either Shifter or Podman HPC. And we have numerous trainings that previously that go over making use of Shifter and Podman. So again, those resources are available for you as well. Okay, how do you run a Shifter container? So once you pull your image before you start, you can use Shifter image pull, and then registry, and then your image and tag. And then in your sbatch script, you denote that with the sbatch command and the image in that location there. And then your srun command, you'll just make sure that you denote that your Shifter is being used there. But we have a number of different examples in our docs as well to show you how to, different ways to use them or as well for setting up. And if you have any problems or questions, again, you can always submit a Nurse ticket or ProMuter ticket. So you have different options as well that you can consider for your Shifter container, such as the volume where it's stored, different environments that need to be made use of, the working environment as well, and other specific modules that you might need to use as well. And so Podman has a very similar feel to it for running a Podman container. So you'll do your pool of your image. And then again, the command that you would run is Podman HPC run, and then your image or the location of your container as well. So pretty straightforward there. I guess the biggest part is, or the most difficult part is just making sure you set everything up correctly to pull the image. Okay, so once you pull or build your images on the login node, you want to make sure you migrate them to Scratch as well. Same thing for Docker and Podman options that are available. Other options that you can use for similar to shifter modules within Podman or, MPI, GPU, and CUDA MPI as well. Do we have any users that know if they will be making use of containers heavily in their work over the summer? We have a few users, so if not, it's definitely a good skill or training for technical skill for you to pick up as systems become more hierarchical and complex. Containerized environments will continue to be the best way to maintain kind of like the structure within your application environment without getting so many dependency errors. All right, so we've talked a lot about running jobs, what is a job, different aspects. So now let's get into a couple of things that can help you with monitoring your jobs once you have submitted them. So how do you see if your jobs are working? So SQ is the Slurm queue. It'll show all of the information about jobs within your queue, so it'll return that information. So within Perlmutter, it can be a lot of information for all of the jobs that are run. So the shortcut SQS can be used for different output options as well. So SQS here shows some previous jobs from a year or so ago that I had done as well as the time that it took for that job to complete. You have the time limit, submitted time, the QoS here, when the job started. If you need to cancel a job that is in progress or waiting, you can use the scancel command. And so with scancel, it sends a stop signal to your job. So you can stop running the jobs that are too long, or if you maybe submitted something with the wrong parameters within your queue. So here's an example, submitting just a job. Got the job number here. We use SQS to monitor it, and then we use scancel to cancel that same job ID. Okay, so that's just a simple way, like if you have a change of heart, you can go ahead and cancel the previously submitted job. And if you want to look at any completed jobs, you can simply use saccount. Provides accounting data for all of the jobs and job steps that you've made use of. By default, it'll show jobs completed within the last day. So different commands that you can make use of with saccount. You can look for a specific job. You can do it by the name or any specific constraint as well. You can also do it by the current state if it's running or whatnot as well. All right. So some best practices that you want to keep in mind with job scheduling, as we mentioned, each job is given a priority value, and that's going to be based on the user, the QoS, and the account. Only 2 jobs per these groupings gain priority at a time, but more jobs can run, but only 2 will age. So that means until those 2 do, the other jobs will just be waiting. The main schedule uses a priority list. So you want to make sure you can give yourself enough time to submit. And then we also have a backfill scheduler that puts shorter jobs in holes that, maybe resources are available to execute them. So it's, getting your job running quickly can be a bit of a game to figure out what parameters. And a good thing to do is also just monitor and see how busy the queue is. A lot of times we'll also send out emails and notices to let people know if the queue is really empty, and now is maybe a good time for you to do some simulations. So some tips, with one job with a large allocation, you have a per node priority aging at the highest and it can get scheduled first. Looking at shorter time length jobs, these are easier to schedule as backfill. You can make use of a workflow manager. And again, choose the right time from Slurm. So balance between enough of your runtime as well as how long you're willing to wait in the queue. And a good tip is always just, again, looking at and seeing how active the queue looks as well. Okay, and as I also mentioned, Nurse has a job script generator that is available. And so with this, you can enter some simple constructs that you need or know about the job that you want to submit. You can select the type of system, CPU or GPU. You can specify a job name, application path that you're going to make use of. If you want the output emailed, there are a couple of other fields, and it'll generate this job script for you to use if you're just not sure or confused about things. All right, so we covered a lot. Hopefully now you know what a job is on Perlmutter. Understand how to run your job interactively or using batch, working with containers for your job, different workflow options. Again, the docs are available in the doc script generator. You can access the doc script generator quickly here, or you just search for it on docs.nurse.gov. All right. Thank you. I know that was a long time. What time? Yeah, that was pretty long, but we made it through.